Great. Well, hello, everyone. It's a pleasure for me to talk to you today about my postdoctoral research on bees and wasps in the Canadian Prairie Sandhills. Not many people know this unless you're from the prairies, but across the Canadian prairies, there are unique tracts of inland sand dunes. And these trace their origins to glacial periods in the Pleistocene when grinding ice, and most recently, the large Laurentide ice sheet reduced bedrock to gravel, sand, and silt. Unlike in many coastal and desert dunes, the sand supply in the prairies is finite. So there's no new influx of sand coming in and no sand being newly generated anymore. And so the dunes are formed and moved entirely by aeolian processes and often take on a characteristic parabolic shape as exhibited by this large isolated sand dune at Douglas Provincial Park in Saskatchewan. The Prairie Sandhills are islands of biodiversity. Their distribution is patchy, and they are threatened by stabilization, which is the fixation of sand in place by encroaching invasive vegetation. As a result, most of the dunes across the prairies have already been transformed into grassland, and those that remain provide a unique habitat for a range of sand-adapted taxa, including several species like this northern prairie skink that are of conservation concern within Canada. Terrestrial arthropods account for most of the animal diversity found on the sand dunes. Despite their diversity, sandhill arthropods aren't very well studied, with the exception of some of the more charismatic groups like tiger beetles and several dune-dependent Lepidoptera. But the dunes provide a rich habitat for many species of solitary bees and predatory wasps on which the effects of stabilization have not been investigated previously. So in a cross-sectional study, I surveyed bees and Aculeate wasps at 13 dunes at various stages of stabilization from southeastern Alberta to southwestern Manitoba. Every site was visited 5 times in the spring and summer of 2019 for a total of 65 collection events. And sampling consisted of a combination of pan trapping and timed targeted netting. So for pan trapping, 30 pan traps were set out along an X-shaped transect in alternating colors, blue, white, and yellow, and set out for about 6 hours on any given collecting day. And while the pans were out, I caught any bees or Aculeate wasps that I spotted on the wing in timed 45-minute sessions. In addition to sampling insect pollinators, the vegetative composition at each site was characterized in 5 1 meter by 1 meter quadrats the last time that each site was visited. So at the end of the sampling season, that's when all the vegetation that would have emerged on the dunes has come out. Now, I'm not a botanist, so rather than struggling with plant identifications on site, I just imaged the quadrats with my cell phone and then teamed up with a botanist at the Canadian Museum of Nature who proceeded to identify the imaged plants in the quadrats to the lowest taxonomic level possible, and also estimated percent plant cover at each site, an average percent plant cover at each site from the 5 quadrats. So overall, more than 12,000 Aculeate specimens were collected, approximately 60% of which were bees and 40% of which were wasps. If you're ever interested in repeating this study, you'll need about 40 drawers to house all the specimens. Although fewer in number, wasps were more diverse than bees in terms of family and generic richness, although the 360 or so species were almost evenly divided between the 2 groups. Some notable and unexpected findings include one new species of sweat bee in the genus Laseiflossum that, to my knowledge, is in the process of being described by Joel Gardner and Jason Gibbs at the University of Manitoba. Multiple morphospecies in several genera also potentially represent undescribed species, although these will need to be studied further. And remarkably, 50 species represent previously unpublished records for the provinces in which they were collected. Most of these are Aculeate wasps that were previously unknown from Saskatchewan, but known from adjacent provinces and states. And so it is just likely that these have been missed in historical surveys because Saskatchewan, for whatever reason, likely wasn't as well sampled for wasps as other parts of Canada. To compare species richness, sites were organized into discrete categories. These include active dunes, which have large areas of open sand, stabilized dunes, which have no patches of open sand, and stabilizing dunes, which are intermediate between the two, and that have a few patches of open sand or blowouts in otherwise largely vegetated areas. And so using rarefaction to account for differences in sampling effort, in this case, that sampling effort was standardized to the number of individuals collected, which is what the x-axis represents. We can see that species richness levels were fairly, were more or less the same among the three stabilization categories. So the y-axis shows estimated cumulative species richness based on the resampled data. In terms of beta diversity, we found that taxonomic turnover, specifically species or morphospecies turnover, tended to be lowest between the sites that were closest to one another, regardless of stabilization level. And so here I've identified the 5 sites that were closest to one another, or most similar to one another, and within just a few kilometers of one another. And in only one case were both sites in the same dune stabilization level category, 2 active sand dunes north of the town of Webb in Saskatchewan. Just for reference, the minimum distance between any 2 sites was just a little less than 1 kilometer, and the maximum distance was almost 800 kilometers. So as you can imagine, my carbon footprint in 2019 was unusually high, although I'd like to think that that was somewhat mitigated by the fact that I haven't traveled anywhere for the past 2 years of the pandemic. So what effect then, if any, does stabilization have on the resident aculeate fauna? Well, we found that the proportion of wasps to bees decreased by about 10% between active and completely stabilized dunes. And a permutational multivariate analysis of variance detected a significant interaction effect between aculeate groups, so wasp versus bee, and stabilization category on species abundance, which means that the 2 groups responded differently to this variable. And for this analysis, the response variables were matrices of abundance columns of 357 species. Not surprisingly, also found that the relative abundance of the 8 species that were identified as sand specialists and illustrated here, which represented almost a quarter of the individuals on active dunes, but less than 5% of those on stabilized dunes, decreased with increasing stabilization. And the same Permanova also detected a significant interaction effect between aculeate groups, so sand specialist versus non-specialist, and stabilization category on species abundance. A closer look at individual species patterns reveals that 3 of the species that were identified as sand specialists were completely absent on dunes that had 70% estimated plant cover or more. 2 species showed significant declines with increased percent plant cover, but the other 3 species, and those are Apornellus basalis, which is a type of spider wasp, Crabodenningi, which is a type of box-headed wasp, and Podolonia argentifrons, which is a thread-waisted wasp, did not exhibit significant linear trends in decline with increased percent vegetative cover. So to understand the relationship between percent plant cover and the abundance of sand specialists, a generalized additive model was tested, treating estimated plant cover as a smoothing term. And we found that total abundance, which was log transformed to improve model fit, was significantly higher in sites that had open areas of sand or active blowouts than sites that were completely stabilized. And after accounting for this effect, we found that the effective percent plant cover did not have a significant, was not significant on non-specialists, and barely non-significant on the sand specialists, which responded non-linearly to this variable. So the explanation for this marginally significant effect is most likely that our estimate of plant cover did not correspond perfectly with dune stabilization category, which was based on the availability of patches of open sand or presence of active blowouts, regardless of vegetative cover. So to summarize, dune stabilization in the Canadian prairies does impact the composition of aculeate communities, with losses of species that are dune specialists observed, with increased dune stabilization. And in general, dunes with patches of open sand seemed to support greater numbers of bees and aculeate wasps than completely vegetated dunes. And finally, the diversity of aculeates seems to be more strongly influenced by geography than by stabilization, at least at the scale, at spatial scale at which we conducted our surveys. So what's next? Well, there are still slightly more than 300 specimens that need to be identified to species/morphospecies. A good chunk of these are male Lasioglossum that I've sent to the University of Manitoba to be identified, as I struggle with those, as do so many of us. And there may also be more sand specialists among some of the poorly known wasps. So I'll have to determine whether our list of 8 species should be expanded somewhat or modified. And I haven't yet looked at possible effects of the dominant plant species type or group on aculeate abundance and diversity. So that is something that I plan to do. And so with that, I'd like to thank the following individuals and institutions for making this study possible. And I thank you for your time. And if we have time, I'm happy to address any questions that you might have. Thank you.
Yeah, thank you for that great presentation. It's cool that you got to find a new species during that time. Carolyn, do we have time to squeeze in a question or two if anyone has one, or should we keep going since we're a little off schedule?
I think we can squeeze in one.
Okay, all right. If anyone has a question, if not, we'll get moving. So there's a question by Molly who asks, did you look at floral diversity or find any interesting diet specialists?
We do have floral diversity data in terms of the types of plants that were in the quadrats. Yeah, I haven't yet looked at the possible effects of presence of plants that occur on active dunes on oligolectic bee species, although there are certainly several plants that occur on the dunes, like Sorlilium lanceolatum, white prairie clover, that are just like magnets for bees. I don't, off the top of my head, know of any species that go to those, exclusively, but that is certainly something that I could take a look at, and thank you for that suggestion.